Chapter 6, Lesson 5 of Geometry, going to wrap up our discussion of these special quadrilaterals by looking at the properties of a kite. And there's only one additional property to a kite other than the sides being congruent, the adjacent sides being congruent, and no sides opposite being congruent. And that is the fact that the diagonals of a kite are perpendicular. So if we draw the diagonals of a kite, they intersect at right angles, which is the definition of perpendicular. Now again, the fact that they're perpendicular creates, you'll notice inside here, these nice little right triangles. And again, once we have right triangles, we know that Pythagorean theorem becomes a possibility as well. So one of the nice things about knowing this is that we can use the Pythagorean theorem then to determine the different lengths of these sides if we need to do that. So one example or one characteristics of a kite, and that is that the diagonals are perpendicular. So we've done a lot of discussing of all of these quadrilaterals now, and there's a lot of things that we should know. So let me summarize them and see if I hit them all. If we have a four-sided figure where where no pairs of opposite sides are parallel, then it could be a kite. And to be a kite, the adjacent sides have to be congruent, so these two sides would be congruent to each other, and then the opposite sides cannot be equal, so these would not be equal. And that makes it a kite. And if it's a kite, the diagonals, if they're drawn, are perpendicular to each other. If you then look at one pair of parallel sides congruent, we're looking at a trapezoid, and there's nothing special about a trapezoid that's congruent. However, if we can classify it as an isosceles trapezoid, meaning the opposite sides that are not parallel are equal in length, then we do have two characteristics that are true, and that is that the base angles are equal to each other and the diagonals are congruent to each other. If you're looking then where two pairs of opposite sides of a quadrilateral are parallel, then we have a parallelogram, and in a parallelogram the opposite angles are congruent, the opposite sides are congruent, and the diagonals bisect each other. Then we look and see if we can't classify that more specifically as a rhombus, meaning all four sides of the quadrilateral or the parallelogram are equal in length. And if that's the case, then we have the additional characteristics that the opposite angles are cut in half by a drawn diagonal, and the diagonals are perpendicular to each other if you draw both of them. If you're looking at the rectangle, then in addition to having the characteristics of a parallelogram, the diagonals are equal in length. And then a square then would contain, because it's a rhombus and a rectangle and a parallelogram, would contain all six characteristics of a parallelogram, rhombus, and kite, meaning the opposite sides are equal in length, the opposite angles are equal in measure, the diagonals bisect each other, the diagonals cut the angles in half, the diagonals are perpendicular, the diagonals are also equal in length. All of those apply to a square. So all of that information is what we have learned in these first 5 lessons of Chapter 6. And again, knowing those different characteristics and then looking at a diagram and then from those relationships being able to write equations is what we want to be able to do.